Good morning, students. Today's topic in mathematics, which we are going to read, is the areas of the plane figures. So concentrate yourself. We are going to start the concepts and the points about this point which you have to remember and learn are: the amount of the space contained inside a closed figure is called the area and is measured in square units. For example, centimeter square, meter square, and kilometer squares. So these are some units for finding the area of something. Second point is to find the area of the figure. Use the formula given in the table below. So here we are given some formulas of some common figures that frequently come in the paper. For example, first figure is a rectangle whose length L and breadth B is given. Formula for the rectangle of the area is equal to L multiplied by B, where L is length, B is the breadth. This concept is going to be clear with the help of an example. For example, we are having a rectangle whose length 6 centimeter and breadth 3 centimeter is given. Area is the requirement. So this is the formula for the area of the rectangle. We will put these values into the formula. Length is 6 and breadth is 3. So these are the values which are put in the formula. Now solve it. This is the area of the rectangle. Here is another example. For example, in a rectangle, we are given the area of the rectangle and breadth is given and length is missing. So we will put all these values into the formula. For example, this is the area that is given. We will put 28 in place of this. Length is missing, that is x. We will put x here, and breadth is 4. So 4 is placed in place of breadth. So these are the values which we have put in the formula. Now solve it from here. X will be 7. Another very important figure is here, that is a square whose side S is given. The area for the square formula is L square. So L is actually S, so that's why area is equal to S square, where S is the length of the side. Now this concept will be cleared with the help of an example. So we are given a square whose side 8 is given. Area is the requirement. So area's formula is equal to S square. So S is 8. So area is equal to 8 square. Solve it on the calculator. You will get the answer. Another question is here. We are given another square whose area 81 centimeter square is given, and requirement is this side. So we will put these values into the formula. Area of the square formula is area is equal to S square. So S is x, so x square will be equal to 81. Solve it from here. Take the square root of both sides. X will be 9 centimeter. Another important figure is here. There are some kinds of the triangles. So the area for the triangle formula is 1 by 2 into base into height. But remember one thing always, that is height is always the perpendicular height. For example, in this figure, this is the height. In this figure, this is the height, and in this figure, this is the height, not this one, because this is the slanting height, this is the perpendicular height. So height will always be the perpendicular one. So these concepts will be cleared with the help of some examples. Now we are given a triangle whose perpendicular height is 7 and base is 10 given. So requirement is area. We will put these values into the formula. 1 by 2 will remain as it is. Base is 10 and height is 7. So we have put these values into the formula. Solve it on the calculator. You will get the answer. Here is another triangle that is given. Area of the triangle is given. Base is the requirement and perpendicular height is given. So first, area is given, that is 15 meter square. The formula for the area of the triangle is 1 by 2 into base into height. So base is x and height is 6. 15 will remain as it is. Solve this equation. You will get the value of the x. Here is another important figure, that is a parallelogram. So the area for the parallelogram is base into height. And remember again, height is the perpendicular height. So B is the base and H is the perpendicular height. A parallelogram is a quadrilateral in which the opposite sides are equal and parallel. So now these concepts will be cleared with the help of some examples. For example, we are given a parallelogram whose base is 12 and perpendicular height is given, that is 5, and area is the requirement. We will put these values into this formula. Area is the requirement, base is 12, that will be placed in place of B, and perpendicular height is 5. So solve it on the calculator, you will get the answer. Here is an other parallelogram. So in this parallelogram, so shaded part is actually the parallelogram whose area is given, that is 36 centimeter square. Perpendicular height is given, that is 4 centimeter, and base is the requirement. So we will put these values into the formula. Area is 36 centimeter square given. Formula for the area of the parallelogram is base. So base is x into perpendicular height, so into 4. So solve it now, you will get the answer. Here is another important figure, that is a rhombus. A rhombus is a parallelogram with 4 equal sides. The formula for the area of the rhombus is base into perpendicular height. So if this is base, the perpendicular to the base will be called h, that is perpendicular height. So base into perpendicular height is the formula. So this concept will be cleared with the help of an example now. We are given a rhombus. Base is given, that is 9.5 centimeter, and perpendicular height is given, that is 8 centimeter. Requirement is the area. So area will be, this is the formula. We will put these values into the formula. Base is 9.5 and h is given, that is 8 centimeter. So we have put these values into the formula. Now solve it on the calculator, you will get the answer. Another important figure is, that is trapezium. So the formula for the area of the trapezium is 1/2 into sum of parallel sides. So these arrows shows the parallel sides. So this side A and B are called parallel sides. So the formula is 1/2 into sum of parallel sides, that is A plus B, into perpendicular height, and this is the perpendicular height, where A and B are the lengths of the parallel sides and h is the perpendicular height. So now these concepts will be cleared with the help of an example. For example, we are given a trapezium. Parallel sides are 6 centimeter and 10 centimeter, and perpendicular height is 3, and the area is the requirement. We will put these values into this formula. So 1/2 will remain as it is. A plus B means sum of the parallel sides. So 6 plus 10 will be into the bracket, multiplied by perpendicular height, so multiplied by 3. Solve it on the calculator, you will get the answer. A trapezium is a quadrilateral with one pair of the parallel sides and one pair of the non-parallel sides. So actually quadrilateral is a four-sided figure in which two sides are parallel and two are non-parallel. Another example is here of the trapezium. We are having another trapezium whose area is given, that is 40 centimeters square. One of the parallel side is given and the other is missing, and the perpendicular height is also given. So the area is 40 centimeters square. Now we will put all these values into the formula. 1/2 of the formula will remain as it is. One of the parallel side is missing, that is x, and other is 9. So we have put these values into the bracket, multiply by perpendicular height. 5 is the perpendicular height. So now solve it, you will get the answer of x. Another important figure is here, that is a circle. The area for the circle formula is pi r square, where r is the radius. Pi can be given as 22/7 or 3.14. So now these concepts will be cleared with the help of some examples. For example, we are given a circle whose radius is given, that is 3 meters. Pi is 3.14. and area is the requirement. So this is the formula for the area. So area is equal to pi r square. Pi's value is 3.14 and r is 3. So we will put 3 in place of r, solve it on the calculator, you will get the answer. Here is another example. So in this circle, area is given now and requirement is the r. So area is given, that is 66 centimeter square, and area's formula for this circle is pi r square. So pi r square will be placed in place of area, 66 will remain as it is, pi's value is given, that is 22/7, r square will remain as it is. Shift all the values to the right hand side, then take square root of the both sides, you will get the answer. Here is another question. In the diagram, ABCD is a parallelogram. AB is 9, this is given. AP 8, this is the perpendicular height. BC is 12, this is the given. So this is base, this is the perpendicular height. Find the area of the parallelogram. So we know the area of the parallelogram formula is base into height. So this is the base 12 and 8 is the height. So 12 into 8 will give us the area of the parallelogram. Second part's requirement is find the length of the AQ. So this is the perpendicular height and this will be the base because this is drawn perpendicularly on this side. So if this is 9, so this will also be 9. So 9 is the base and perpendicular height is the missing. So AQ into 9 will be equal to area, which we have find out in A part. So AQ into 9 will be equal to 96. So look now, 9 into AQ is equal to 96. From here we will find the AQ, that is the requirement of the second part. Another question is here. In the diagram, ABCD is a trapezium. AD is 5 centimeter, this is given. BC is 9, so 9 is this one. So these parallel sides are given. AX is 4, this is the perpendicular, that is given. Calculate the area of the trapezium. So the formula for the trapezium's area is 1/2 into sum of the parallel sides into height. So now we will put all these values into the formula. 1/2 will remain as it is. And parallel sides are given, these are 5 and 9. So 5 and 9 will be placed here and perpendicular height is given, that is 4. So 4 will be placed here. Solve it on the calculator, you will get the answer. And other question is here, the area of the trapezium PQRS is 289 centimeters square. So area of the trapezium is already given. Find the length of the RS. So RS is actually one of the parallel sides because the other side that is parallel is given and the perpendicular height is given. So first we will put the formula of the area of the trapezium 1/2 into sum of parallel sides. Parallel sides are PQ and RS into perpendicular height. So this is the perpendicular height is equal to area, that is 289, that is given. So now we will put these values from the figure into the formula. 1/2 will remain as it is. One of the parallel side is given 23 and other is missing, that is actually the requirement. Into perpendicular height is given is equal to area is given, that is 289. So now solve from here, you will get the answer. Another question is here. The trapezium has the same area as the parallelogram. Find the value of the x. So this is the trapezium and this is the parallelogram and it is given the areas of the both figures are same. So first we will find the area of the trapezium because parallel sides are given and perpendicular height is also given. So the area of the trapezium is 1/2 into sum of parallel sides into height. Parallel sides are 9 and 15, perpendicular height is 7. So we will put the values into the formula, solve it, you will get the answer. Okay, now find the value of x. So this base is actually the requirement because perpendicular height is given, that is 7, and the formula for the area of the parallelogram is base into perpendicular height. So x into 7 will be equal to the area of the trapezium because the areas of the both figures are equal. So 7 into x will be equal to 84. So 7 into x is equal to 84. From here the value of the x will be solved. And other question is here, the area of the circular flower bed is 13.86 meters square. It is surrounded by a tiled path that is 1.4 meter wide. So this is the tiled path that is 1.4 meter wide. This is flower bed whose area is given, that is 13.86. R is missing because find a part the radius of the flower bed. So because this is a circle, so the area of the circle is pi r square. So pi is 22 by 7, r square is the radius, and because area is given, that is 13.86, so that will be equal to this one. And from here we will find the value of r. So this is done, a part is done. B part's requirement is the area of the tiled path. So this dark gray color is the tiled path whose area is the requirement now. Now r's value is here, that is the square root of 4.41, that is 2.1 now. So actually this portion can be solved by subtracting this lighter gray part from the full circle. So that will be equal to pi r square, the bigger capital R, that is r plus 1.4. Look here now, area of the tiled path is 22 by 7 multiplied by 3.5 square, because this is 2.1 and this 1.4 will make in total 3.5. So 3.5 is the radius of the bigger circle. So from the bigger circle we are subtracting this smaller circle whose area is already given in the question, that is 13.86. So solve it on the calculator, you will get the area of the dark gray color. Statement of the question is find the area and the perimeter of each squares. All measurements are in centimeter. We will find the area only because this lecture is about the area of the plane figures. So for example, this is a square, this is given. So area of the square formula is L square. L is the length of any one of the sides, so lengths given are 8.5. So 8.5 will be placed in place of L. This square will remain as it is. Now solve it on the calculator, you will get the answer. Unit will be centimeter square. These two parts are same. Here are the values of the any one of the length. You will put the formula, put the value into the L and you will get the area. So these questions are same, only values are different. The statement of the question is find the area and perimeter of each of the rectangles. So this is rectangle. All measurements are given in the centimeters. So the formula for the area of the rectangle is length multiplied by width. Length is given, that is 11, and width is 6. So 11 6 are 66. Unit is centimeter, so area is always in square units, so 66 centimeter square is the answer. These two parts are same, dimensions are given. If area is the requirement, you will put the values into this formula. Area is equal to length multiplied by width, so you will get the answer. The statement of the question is find the area of each triangles. All measurements are given in the centimeters. So the area of the triangle formula is area is equal to 1 by 2 into base into height, where height is the perpendicular height. So this is the base and this is the height. Height is always perpendicular height. After solving it on the calculator, you will get the answer. Area is always in square units, so centimeter square will be the unit. In this triangle, this is the base, this is the perpendicular height. In this triangle, this 4.5 is the base and this 9 is the perpendicular height. In this triangle, this 28 is the base and this 30 is the perpendicular height. In this triangle, this 6x is the base and this 3x is the perpendicular height. In this triangle, 4x plus 1 is the base and 2x is the perpendicular height. So put these values into the formula. Formula is 1 by 2 into base into height. This is the formula for the area of the triangle and you will get the answer. Statement of the question is find the area. Now we will find only area. Circumference is not the requirement today for us because this lecture is only about the area of the plane figures. So find the area of the circle. So for example, if we want to find the area of this part, the area of the circle formula is pi r square, and r is actually the half of the diameter. So if 56 is the diameter, so pi's value is 22 by 7, and then r will be 2 2s are 4 and 2 8s are 16. So this is the radius and this r square will remain as it is. Now solve it on the calculator, you will get the answer. The unit will be in centimeters squares. So if you want to find the area of these two parts, the radius is given 14 and in this part 3.5. Just put the values into the formula of the area of the circle. You will get the area of these two parts as well. Statement of the question is find the area of the parallelogram. All measurements are given in the centimeters. So the formula for the area of the parallelogram is base multiplied by perpendicular height. So this is the base, that is given 14, and to which is this one is the perpendicular height, so 9. Solve it on the calculator, you will get the answer. Unit is in centimeter squares because area is in square units. So this part is same. This is the base, that is given 8, and this is the perpendicular height. So you will put the base and perpendicular height into this one to get the answer of this part as well. Here is another question. Find the area of each trapezium. All measurements are given in centimeters. So the formula for the area of the trapezium is 1 by 2 into sum of parallel sides multiplied by perpendicular height. This is the formula for the area of the trapezium. Now we are going to apply the values. 1 by 2 will remain as it is. Sum of parallel sides, so 25 and 15 are parallel sides. These arrows can be seen. So 25 plus 15. And perpendicular height is given, that is the height between the parallel sides, that is 12. So solve it on the calculator now. You will get the answer. Unit will be in centimeter squares. This part is same. Here are the parallel sides 10 and 7, and here is the perpendicular height. So put the values into the formula, you will get the answer. Here is another question. Find the value of x in each of the following. These types of the questions are about the areas. Because this is a parallelogram given, opposite sides are parallel and equal and none of the angles is 90 degree. So if this is base 28, so this will be the perpendicular height because this is the perpendicular onto this side. So 28 into 16, this is actually the area of this parallelogram. The area can be found out from another way. If this is the base, that is 20, so then this will be the perpendicular height. So these two are areas of the same parallelogram, so that's why they are equal. And from here we can find the value of x by shifting this value to the denominator of the left side and solving it on the calculator. You will get the answer. Unit will be in centimeters. This part is again same. This is a triangle, so we will find the area of the triangle by two different angles, two different sides. So if this is base, then this is the perpendicular height. So this is the area of this triangle, and this can be, the area can be find out from another side. That is, if this is base, that is 25, and this is the perpendicular height x. So solve this equation, you will get the answer of x, that will be in centimeter, that will be in meters. Here are trapeziums whose area is given, and missing value is the requirement. So if area is missing, area is given, so we will put the formula of the area of the trapezium, that is 1 by 2, into sum of parallel sides. Parallel sides are 13 and 6, into perpendicular height, that is x. So that should be equal to area, and area given is 38. So solve this equation, you will get the answer of x, and x will be in centimeters. This is the same question. So if this is 36, this will also be 36, and this is the perpendicular height between the parallel sides. This is the area. Put the values into the same formula, you will get the answer. The statement of the question is the length of a rectangle is 6 centimeter and breadth is 3x. If the area is at least 72 centimeters square, find the range of the values of x. So area of the rectangle formula is length multiplied by width is equal to area. Length is given 6 and width is given 3x. And this is the area, and it is given that area is at least 72. So at least 72 stands for this, greater than or equal to 72. From here, solve it. 72. This 6 and 3 will come to the denominator. 6 ones are 6, 6 twos are 12, and 3 fours are 12. So the range of the values are x is greater than or equal to 4, because range of the values of the x are the requirement. Statement of the question is, in the diagram ABCD is a parallelogram, EC is 4, and the area of the parallelogram is 3 times the area of the triangle ABE. So area of parallelogram is equal to 3 times of area of triangle. So now we are going to put the values. For example, A, B, C, D, and here is E. So let's suppose this point is F, and this is the perpendicular height of both parallelogram and triangle as well. So the area of the parallelogram will be BE plus EC. BE plus EC is 4, and this is the perpendicular height, that is DF. On the right side, 3 will remain as it is. Area of the triangle formula is 1 by 2 into base. Base is BE, and perpendicular height is DF. DF will be cancelled on both sides, and okay, here is BE plus 4 now, and on the right side we have 3 by 2 of BE. Solve this equation, you will get the answer of BE. So BE will go to the right hand side, so 3 by 2 BE minus BE is equal to 4. Solve from here, you will get the answer of BE, and this was the requirement. The statement of the question is, in the diagram, the area of the parallelogram ABCD is 288. So ABCD is a full diagram having an area of 288 centimeters square. BEEF FC are equal parts. AD is 24. And find the area of the trapezium AEFD. AEFD is the requirement. Okay. So first, from the area of the parallelogram, we will find the perpendicular height of the parallelogram by putting base, that is 24, into perpendicular height. So this is base into perpendicular height should be equal to the area of the parallelogram, that is 288. From here, you will find the height. That will be in centimeters, so this will be, find it out. Okay, now the requirement is find the area of the trapezium. So if this total is 24, so this will be 8, this will be 8, this will be 8. So now the area of the trapezium, the formula is 1 by 2 into sum of parallel sides into perpendicular height. So this side and this side will be parallel. So parallel sides are 24 and 8, and perpendicular height we have find out just in the previous part, that is this one. So put the values into the formula, you will get the answer.